Hi again, everyone. We are starting the logarithmic functions. We are doing the introduction right now, and we're going to start with the logarithms and what they are. So, when solving exponential equations, we have the tools to do this only when we can create two like bases. So, a to the power of x equals 1 over square root of 2. 8 in this case is the base. X is the exponent, 1 over square root of 2 is the result of raising the 8 to some kind of exponent. What is the exponent though? This is when the log comes in and help us determine which exponent we need to raise the base to get the answer. That's what the logs are for. So, how can we solve 1 over 2 to the power of x plus 1 equals 3 when we can't create like bases? Here we go, starting with the graph, and look at our exponential and function and its inverse. So if we want to graph y equals 10 to the power of x, let's assume that our base goes from 0, 1, 2, and so on. And then therefore our y will be 1, because 10 to the power of 0 gives me 1. 10 to the power of 1 will give me 10, and 10 to the power of 2, or 10 squared, is going to give me 100. And here I'm plotting it. X is 0, y is 1, x is 1, y is 10, x is 2, y is 100. For the inverse, remember that for the inverse we're switching x and y. So now my x is 1, y is 0, x is 2, y is 100, and so on. Okay, so there we are. The inverse function of the exponential function is going to be a logarithmic function. This is where log function comes in. It's just an inverse of the exponential function. So, what is log? Log helps you determine which exponent your base was raised to give you a certain answer. So, y equals 10 to the power of x. From here, x, the exponent, equals log of the base of y, of your answer, or log y, because log is already base 10. So if there is nothing right here, if there is no 10 for base, it means it's log 10. In your calculators, it won't say 10, but you always assume that it's log 10 of something. Unless there is a different base, but we'll get to that later. So, answer equals base to the exponent. From here, exponent equals log of the base of the answer. So y equals a to the power of x, where x equals log of a of y. Okay, so again, x equals log of 10 of y means x is the exponent to which 10, the base, is raised in order to get y. So when we are dealing with the logarithmic expressions, the variable on the left or on the right of the equal sign is going to be your exponent, and the other side will be log, base, and answer. Let's look at some examples and see how that works. So, write an equivalent exponential statement for log 10 1000 equals 3. 3 is the exponent, 10 is the base, 1000 is the answer. So, 10 was raised to the exponent 3 to get 1000. And that's what we wrote here. 10 to the power of 3 equals 1000. So, which exponent did I raise my 10 to get 1000? I raised it to the exponent 3. For next one, 3 to the power of 4 equals 81. I want to write it as a logarithmic expression. So log of base 3 that will result in 81 tells me that I have to raise my base to the exponent of 4 to get 81. So 3 to the power of 4 will give me 81. Alright, find log 10 of 100. So here's the hint for you. Which exponent was 10 raised to get 100? It was raised to the power of 2. Find log 2 of 32. Which exponent did you raise 2 to get 32? You raised it to the power of 4. 2 to the power of 4 will give you 32. Okay, here's a tricky one. Log 5 of 0.2. Which exponent did you raise your 5 to get 0.2? When your answer is a decimal, it sometimes makes sense to turn it into a fraction. Because remember, when you get a fraction, it means that your exponent was negative. Also, it shows you what was your base and which exponent it was raised to. Look here, 0.2 is the same as 2/10, right? So 2 over 10 can be simplified to 1 over 5. So log 5 of 1 over 5 is the same thing as log 5 of 0.2. Now, to get 1 over 5 from 5, I have to raise my 5 to the exponent of negative 1. 5 to the power of negative 1 gives me 1 over 5, which is the same as 0.2, because if I multiply it by 2, I'm going to get 2 over 10, which is 2/10. So log 5 0.2 equals negative 1. Alright, if we only work with variables, log A is my base, a to the power of n is the result, it's your answer. So which exponent was a raised to get a to the power of n? The exponent is n. So log a of a to the power of n equals n. B, log of 2 of 1 over square root of 2. Okay, so which exponent did I raise my 2 to get 1 over square root of 2? Remember, square root of 2 is the same thing as 2 to the power of 1/2. You'll have to recall the exponent rules here, guys, because without them, you won't be able to do any of this. Unless you have a calculator, but sometimes you'll be asked to do it without a calculator. So, square root of 2 is the same thing as 2 to the power of 1/2. 1 over square root of 2 is 2 to the power of negative 1/2, because 1 over something means that you raised it to a negative exponent. So, log of the base 2 of 1 over square root of 2 equals negative 1 over 2. That means that you raised 2 to the power of negative 1 over 2 to get 1 over square root of 2. Now, if we use a calculator, sometimes we just simply can't calculate it without a calculator, so we have to do a calculator. Use a calculator to find log of 1000. Remember, when there is nothing here, when there is no base, we assume that it's a 10. So log 10 of 1000 equals 3. Number 10 was raised to the power of 3 to get 1000. Log 52 equals 1.7. Which exponent did you raise 10 to get 52? You raised it to 1.7. In a calculator, all you have to do is enter log and then the number 52. You don't have to enter 10 because log is automatically already pre-made so that it's at base 10. So log and then number 52. All right, what happens though if your base is not 10 and you want to find using a calculator? Look at this example, log 2 of 10. To enter this in a calculator, the easiest way would be to do log 10 divided by log 2, and that will give you 3.32. So that means that to get number 10, the answer 10, you have to raise your 2 to the power of 332. So again, in a calculator, enter log 10 divided by log 2. Okay, so again, we're doing our homework in class, asking all possible questions, not wasting our time, and succeeding on the test. Can't wait to hear your questions. See ya!